Hello friends, today our topic is data structure asymptotic notation. So let's begin. What is data structure? Data structure is simply means organized data in computer. The logical or mathematical model of a particular organization of data is called a data structure. The data model depends on two considerations. First, the actual relationship of data in the real world. Second, the structure should be simple enough that one can effectively process when necessary. Types of data structure. We are using 4 types of data structure. The name is array, linked list, trace, and a graph. You perform some operations on data structure. The name of the operations which we are performing in data structure is 6 basically: traversing, searching, insertion, deletion, sorting, and the last, merging. Complexity of algorithm. The analysis of algorithm is a major task in computer science. In order to compare algorithm, we must have some criteria to measure the efficiency of our algorithms. Suppose M is in an algorithm and suppose N is the size of the input data. The time and space used by the algorithm M are the two main measures for the efficiency of M. The time is measured by counting the number of key operations. The space is measured by counting the maximum of memory needed by the algorithm. The complexity of an algorithm M is the function Fn, which gives the running time or storage space requirement of the algorithm in terms of the size of n of the input data. The two cases one usually investigates in complexity theory. Worst case, the maximum value of Fn for any possible input. Average case, the expected value of Fn. Sometimes we also consider the minimum possible value of Fn, called the best case. Rate of growth of complexities. We use graph for that thing. There is a two options for time and space. We are follow these two for finding our complexity in algorithm. There is a constant time function of O1. There is a logarithmic time O log n, and there is a linear time O n, n log n linear rhythmic time, and there is a to the power n quadratic time, the highest complexity value, n factorial time. Big O notation. The function we are use Fn less than equal to Cgn, n greater than equal to n naught, C greater than 0, and n naught greater than equal to 1. Fn equal to Ogn. There is a graph Fn function and there is a Gn function. Sometimes Gn are lesser than Fn, but after some time it will be increased. And there is a n naught, n is a space, and time. Big O notation define an upper bound function Gn for Fn, which represent the time space complexity of the algorithm of an input characteristic n. Big omega. Fn omega Gn Fn greater than equal to C dot Gn. There is a graph, time, and n, which represent space of code, how many bytes of code, and there is a n naught, there is Cgn. You start from upper and after some time it reduce. big theta. C1 dot gn less than equal to fn greater than equal to C2 dot gn. C1 C2 greater than 0 and n greater than equal to n naught. Fn equal to theta gn. There is the same graph, time and space, which represented by n. There is a 3 line C1, Fn and C2. There is a Fn which start the same point at the C1 and C2 start. For some time it higher both of them, and after that it will between both of them, C1.gn and C2.gn. There is a n naught initial point when if Fn bound with C1 and C2 is called theta. Thank you for watching. If you like it, then subscribe and hit the like button.